All right, we are back again here. So we have now already defined our steps until the groove, and meanwhile I have defined a second outside groove for our geometry, and I call it groove OD underscore 2. And now we need to define our next operation, which is the outside diameter finishing or finish OD. So maybe I can show you first the slides here. So we have gone till here, and this is the starting point. So we need to create a operation, finish turn OD, specify the tool, and now we need to choose the containment. And containment, for the vocabulary that you are using, you can remember that there is a risk of colliding with the spindle, so that's why we are using containment. And lathe finishing, of course. Also pay attention to the parameter settings that you are selecting. Because this is the finish cut, so it should be low feed rate, low depth of cut, so that we can reach a better surface quality at the end. Then we have the different cutting regions that we need to define. We can see where are the problems come from. So we have the groove, so we need to kind of jump from this one and still continue. So we are defining the multiple machining region and always in the single direction. And then we can see that if there are some problems coming, then we can actually ignore some members to make sure that the path is generated correctly. I will go now to the software and start doing this, and we can see if we reach any problem. So here I have the finish OD, the same program. Let's say I want to use this one, containment, finish lathe, everything is fine. I just call it 1 because I don't know if I will need to define these 2 or not, but just in case, I now click OK. And then what I will do is that first maybe I can just generate and see that if there are some problems happening. So verify, and then I can see that now there is something, and then it stops. Of course, it stops because it's now only understand this member to finish it. But now I have 2, 3 members. So what I need to do is that I need to define multiple machining region. So for those ones, I need to define the cutting region. First of all, I need to define the range. So I will get to the axial point 1. I will specify it from the beginning. I want to be machined from here till specify point number 2, which is here. So I don't want this plunging to the part where I have the material for the cutting. So I have it till here. So this is okay. And then still I needed to define that there are different multiple regions. So currently now 1, 2, 3, it understands it 3, but by default the machining region is 1. So I search it for multiple, I choose it to multiple, and then single direction. So I think now we are good to go. After that, well, let's try to see what will happen here. So I have it clear now here. So I can see now there are 2 problems existing. One of them is going toward this part, and then like this is the part that needs to be kind of avoid to move all these, and these ones, and also this chamfer is not perfectly done. For this chamfer, most probably the correct approach is to define once the movement from here and then here. So I need to define maybe 2, 3 different operations. But for the sake of the time, I will ignore now solving this issue. I will now try to solve this issue so that the tool doesn't come here. So for this one, I need to go to actually, yes, here, custom boundary data. So all of these points that you can see, they are now called with a member. And I can see the list of the members here, or I can just simply click here. So this member, I can customize and say that ignore this point. And well, currently I only did that, do that, and then let's see if it solves any problem. Not much, so let's do again. Even though it's not a major problem, but it's better to solve it. But let's see if it goes fine or not. If not, then perhaps just by cutting the regions in 2 by 2, then it would be easier to solve. But for now, let's see if I can select this one. Now I have the ignorance only in member 24. Then I have member 23, which is the bottom here. And then I try to put also ignore to this one. And now I can see that there is a problem here. So it somehow jumps to this one. So this is not what I'm looking for. Yes. So definitely this is an error. So I don't want that. Let's go back and cancel this member 23. I guess it was the bottom one. Even though the bottom one should be ignored, but I think when I define these 3 different regions, that is how it somehow wants to jump to the next region. So this is the one, so do not ignore this one. Even though I have main fine finish. So as I said, you just need to a little bit play with all these and see that which one is the correct option. So now I have this ignore member, but for some reason I have also this one. So might be different scenario. Well, let's try this one and see how does that work. It looks a little bit better. I verify that. At least this curve is okay. This is okay. And now the only problems now appears to be here. So I think I can do the same thing and then react this one. So the only issue now it remains to this chamfer here that we can anyway later on take that to a special look. So now this is this is done now. I can see that it appears here. Well, ignore now these 2 errors here that we can later on check it out. I don't want to now disfocus this part of the exercise session, so we can go to the next one. So next it would be to defining the rough bore of an inside. So here we need to define the internal tool to another station. So we can see now I was trying to define the internal tool for the odd number. So for example, maybe number 6 or number 8 if it is available in my turret. Then here we're just specifying different type of a holder. So this is something that we have talked about it in this tutorial. They try to also remind you that this is important to define it here, especially for the internal one. And then for the sake of this presentation, again, we will not enter the holder value, but this is absolutely important to consider, especially the internal diameter cut, so that we would be checking also the collisions also. Then after that, defining the type of the program, it's again avoidance, lathe rough, and then now here again we have the reversal mode, and reversal mode is avoid going toward the groove area that is not yet created, the internal groove. And for that one, we need to also specify the non-cutting move to be able to remove or avoid any collisions during the things. And then after that, we're going to generate the tool pass. So I'm going to now pause this and go back to the software, and we're going to implement it and to see that if we have some errors. All right, now we come to the point that we can actually start the defining the internal diameter. So we need to first create the tool. Creating the tool, we are basically here, ID. So internal tool, for example, I can just select 50, 60, and then I could even write the information about the tool itself here. Of course, I need to best case define the holder, but for this case now I will just avoid using the holder so that it saves a little bit of our time. Let's say our nose diameter is this much, so these are the value that I'm taking it from, for example, a catalog. Then this one we can set it, for example, to, let's say, 4. So we have a smaller one, so then the holder would be able to go through. This tool number is correct. And now I have the tool here. So then I will create the operation. Then after that, we have the rough bore ID. And be very careful that you are selecting ID here. Then here, avoidance, rough. So we're gonna go create the part itself. So by the experience that we got from the grooving here, we know that we have 2 grooves here. So I won't check it now here because we know that there would be a problem. So I will now put the reversal to omit so that we omit to going through the grooves here. And then going to check it again. So I don't repeat it anymore, but of course the spindle values, the movements, and also the parameters and even the number of passes is something that needs to be checked. But now we just go for the default setting now, but definitely you need to check those ones with your specific program that you are making for your assignment. So this is a bit too slow movement, but anyway, for the simulation only. But we will just see about these few passes. There are 4 passes, and normally it should not go inside the groove, since the groove is not yet made. So we don't want to plunge the tool inside the part in vain. Now this should be the last point, and now it goes to the starting point. So everything looks okay now. So this is done. Next one from the presentation, we can now go and define the same thing, but the finishing one. And for the finishing one, of course, we need to define again the trim point at the end of it by specifying the end of the curvature, for example, and also check about the non-cutting movement and generate the tool as always. Next in the list is defining the internal diameter of finishing. So these are the different sections. So we need to define it by different elements of the operation, but I'm now defining only one of them. And I think you can define the rest of it based on what we have taught here. So I will just create the operation. I'm now creating only for this one, but of course you need to have another one for this and another one for this and then another one for these elements. And we need to each time omit the groove itself. But now I'm going to create for this curvature. So now groove ID, now I have it here, sorry, rough bore ID. I have the ID tool, avoidance, lathe finishing. For example, I can just call it 1 now because it's going to be several of them. I click this one. And then after that, of course, by the experience, we know that it's going to go toward the groove. So anyway, even if it might not be useful or not, anyway, we're going to have it omit here. Then I'm going to limit the cut region to the end of the curve. For example, I'm specify trim point 1 at the end of the curve so that I can just cover here. As I said, you have 1 for this one for another element, and for the other one. So you need to define it one by one. And then after that, well, I can already check what is this giving to me and verify. So now this looks already fine. There was no collision, but in case there was some collision, of course, then I have the cut section here, and then I could perhaps define the departure to some maybe as it was said in the tutorial of the presentation that I showed earlier. It is clear, axial, and direct in case there was some problems, but you can actually define different scenarios. So then we need to repeat these sections, this finishing for this section, this one, and the other straight section as well. So we are supposing that this would be done. Next would be to defining the groove. So I can quickly define these ones and see that if there would be any problem or not. Otherwise, it should be basically similar to what we have done to the outside diameter groove, except that, well, this is, we need to create another groove as well, and then putting it to station number 8. Defining the holder, again, for the sake of this presentation, I will not do it for the holder, but you should definitely do that for your assignment for sure, to check for the possible collisions. And then the avoidance is the geometry, lathe groove is the other one, and of course then defining the specific ones. I think this is the same one, except that when we were doing the outside diameter, we were choosing the root of the groove, and here it looks like that we need to choose the crown of the groove. I will check it, and then I will again back to recording. Now we need to create the groove. Now we have the internal groove here. Then we're gonna give it to 8. Then I think this was 5, so we need to choose the groove small enough. Let's say what will happen if we choose 3. Then of course this is a bit too big, so insert length. What will happen if it is 8? So now I'm just choosing some random parameters, but of course, as you can see, the holder is now too big. Just to not to complicate the things, I'm now starting a smaller groove. Well, maybe I can still even make it smaller. Radius doesn't matter. And then this one too. So now we have a smaller one. All right. Now I have this one. I'm going to go create the operation real quick. Now we have the operation tool of ID groove, avoidance, and then the groove itself. It's gonna be groove ID, and then I have the first one, and then I need to do the second one as well. Then after that, I will have to define the cut regions. I will define the cut region based on the for the groom itself on top of the crown, as it was said earlier. So it is in contradiction with the outside groove. And then I will use the trim point 1 and trim point 2. Trim point 1, I will specify this one, and let's say I will choose this one, and specify 2, I will choose the crown one. And then let's see if I need to actually change the non-cut movement. It looks like, because I can see that it's already in there's already colliding here, so I can go here, then I can go to this non-cut move, then I can go to the approach. So here I have the approach, then motion to start, I can change it to radial to axial maybe. So first radial and then axial, and then maybe I can just put this is to approach. Let's see if I can use, let's see if I can define it here. I can later on change it, and now I'm just testing it. And motion start to engage, which is here. Then I have this one also radial to axial. So this looks all right. Perhaps we can later on check it out. Then I can go still to the departure tab. And then, so this is also the most complicated part, that it might be a little bit of focus or practice to remember it by heart. Then we can go to the motion start points. Then after that, I can define actually again radial to axial. And then specifying points, I will specify it here, and then option points. Then for example, this one, I can put the points and define again another points here, and then click. Let's see if there is any collision or not. Of course, I need to check with the holder. It might be that I need to still move this point somewhere in the center. I generate the points, and then now I will just verify that one. And let's check it out. It looks like now I have a problem here. There is definitely a collision here. So it means that I need to go to these movements again. So, oh, sorry, not this one, not non-cut movements. And maybe we'll move one of these points more to the center. So let's say maybe the last one, the one in the departure, let's put this one, or this one that I need to select. Maybe let's put it more in here, and also this one, let's put it more around the center line. And I hope that now the problem is solved. I will regenerate again. So this is the part, this non-cutting movement. It needs a little bit of practice and also trial and error. And that's the whole part of having it software, so that we can try it and we don't need to experiment it on the machine. So this is done. So meanwhile, I could define the same approach for the second groove, but for the sake of this work, I will now avoid that, and I will go to back to the presentation mode so that we can continue. So this was about the groove and non-cut movements of the groove itself, and now we have the finish bore, or finalizing the rest of the places. So as you remember, we have only covered this curvature first, and now we have to create the bore. So we have the rest of the parts itself that we can define by these two trim point 1 and 2 to define the rest of the bar itself. So I'm not going to do that, but I will just show you the presentation here so that you can follow it and test the different scenarios so that you can generate the rest of the internal diameter finishing. And after that, we have the threads. So already, if we can see, we have already filled up the turret perhaps. So then, of course, it depends how much space we have in the turret. So here we can see that the tutorial guide us to define and to create the tool, and this time create a turret station. We create a turret, and then we can define it to the new station so that we have another pocket number. External and internal thread cutting, we might have right hand or left hand cutting. So similarly to any other processes, we need to first create the tool itself. So these sizes are depending on what kind of a catalog we have or what kind of a scenarios we are facing. Then after that, we're going to create the thread. So here again, avoidance, lathe thread, and also correct tool unit needs to be selected. Then after that, we are going to select the crest line of the thread itself and our method. So for example, this is depth and angle. Then we are defining the different depth and angle sides. We are defining the offset from the beginning, offset from the end, and then cutting parameters. We need to insert the pitch tab and provide the different values, and then don't forget um, to verify it for the collision and also verify the whole tool. So after this step, we have only or yeah, these are still missing, but the specifying the non-cutting movement, of course, for the non-collision and that kind of thing. So now the only operation that left to be go through is the cut of the part. And the cut of the part is basically is the same thing that you are using with the same groove groove tool, except that now the holder should be in a way allowing you to going through the part. Depends on how big the diameter is, it might be possible to do or not. So for example, if you can see the groove number 1 and 2 here on the bottom, it is not allowing us to go through the whole part since the holder will be collapsing. However, on the left side, you can see that the tool is allowing us to do that, or even the number 3, or this specify one on the right hand side. So with these ones, we are able to cut off the part. This is something that some of the workshops they are trying to do. Sometimes it's not. So it's not very common approach to do that. But anyway, I think that it's good to have the skills to define the cutoff approach. So again, the cutoff approach would be acting on the avoidance. So for remembering all what we have done, only the rough outside was the only thing that we needed to define on the containment. Everything else was on the avoidance. Lathe finish is the last step that we are going to define. We define the cutoff position by creating the part operation cutoff, defining the positions, and then we are defining the feeds and uh, speeds as always for all the operations. And then we are allowing some kind of a length or in terms of a percentage. For example, now you can see that this 10%, so this 10% is the percentage that we are going over so this will cause the cutting feed rate to slow down to 25% and the current feed rate to at least 10% of the cutting path when we are reaching to the center. So these two values of 25 and 10 is for decelerate in the specified millimeter. So 10 millimeter before reaching uh, the center, since it's going to be a very small amount of the part available, and with the huge force and huge speed of the tool that we have, and we are cutting the part. So if we are going with the same speed, with the same feed, we might have actually we might mistakenly create a deflection on the component rather than really cut it through. So that's why it is better to uh, reduce the acceleration or reduce the speed. Like for example, here by 25%, is the software is suggesting, but we can of course change it in the last 10 millimeters. So the more we are going to the axis, the more we should reduce the speed or decelerate in a sense. All right. So after this, we have already done all the operations, and then next needs to be done is the output. For this lathe machining, we are not using any specific post processor in the university, but for milling, we are defining a specific post processor. So for the moment, I'm not going to go through the post processor for this exercise, but I already put the material. You can take a look. And then the next one is actually to get to extract the shop documentation. For example, where we can have the part name, the material, the pictures, and then different operations and the tool name. So this is very important that if you have already given a good name to be able to communicate it with your operator or for yourself to go over it again. And then again, if you go to the And if you follow out the output shop documentation, this instruction, you should be also able to create um, an operational file like a PDF file or Excel file as a report of what are the steps need to be done, or what are the tools that has been done, and create the list of the tools and create the list of operation and so on. So I hope that this exercise session, this tutorial was perhaps rather long, but I hope that it would be helpful for you to follow now your assignment. And then for the assignment, I will attach one assignment instruction in Moodle, and you can follow that, and we will make another video for the next week assignment, which is the mill turn or milling assignment. Stay tuned. Thank you very much for your attention.